Alright, so in part C of example number 1, now we're doing our double angle identities. I'm going to do my best to remember that my answer should be in radians and not degrees. And I know it's a double angle right here because it says the tangent of 2x. So what I'm going to try to do is get this tangent 2x by itself. So to do that, I am going to divide both sides by 3. So I'm going to get the tangent of 2x, or double x, equals radical 3 over 3. Now, I am going to do this in a way that I know isn't going to work first. Alrighty? And I'm going to do that to try to show you that sometimes what we think doesn't always work. So what I'm thinking to myself is, I am going to use the double angle identity because it's a double angle. So tangent of 2a equals 2 tangent a over 1 minus tangent squared of a. There we go. I'm going to use this identity to get radical 3 over 3, or to solve for x. So I'm going to take out the tangent 2x, and I'm going to plug in the identity. So 2 tangent x over 1 minus tangent squared x, we know equals radical 3 over 3. All right, we have a fraction that equals a fraction, so I am going to cross multiply. So we're going to have 6 tangent x, 3 times 2 tangent x is 6 tangent x, equals, now I'm going to distribute the radical 3 to both of these. So that's going to be radical 3 minus radical 3 tangent squared x. Because I have a tangent and a tangent squared, I'm thinking, hey, let's see if this factors, or maybe use a quadratic formula or whatnot. So I am going to add, I don't like my tangent squared or my squared term to be negative. I want it to be positive. So this is what I'm going to move everything from the right over to the left. So I'm going to say radical 3 tangent squared x plus 6 tangent x minus radical 3 equals 0. I moved everything from the left over to the right by doing the opposite signs. So I'm going to take the value in front, a, and I'm going to multiply it by the value in back, c. So I'm going to do a times c, and radical 3 times negative radical 3 should be negative 3. And then I need those same numbers to add up to the middle term, which is positive 6. So are there any values that multiply to give me negative 3 that add to 6? And that answer is no. No values multiply to give me negative 3 that add up to 6. So instead of factoring, I would have loved to have factored, but it didn't work out for me. Maybe I could do quadratic formula, but I'm going to see if there's something else. So if I go all the way back to here, the tangent of 2x, what we can do is we can use this information to look at our unit circle. So where is tangent radical 3 over 3? So you want to figure out, when I do y times the reciprocal of x, where do we get radical 3 over 3 on my unit circle? And that is at, oh my goodness, that was just not a good. Why don't we do this? Select it, delete it. There we go. That's going to be right here, since we're in radians, with the reference angle of pi over 6. So when we are at pi over 6, that's going to be the point radical 3 over 2 and 1/2. Well, does that happen anywhere else? Yeah, it's going to happen with the reference angle of pi over 6 down here, a negative and a negative. Again, I've got a reference angle of pi over 6 because this point on my unit circle is going to be negative radical 3 over 2 and negative 1/2. So we've got pi over 6, and pi plus pi over 6 is 7 pi over 6. So that's where that happens at. It happens at pi over 2. I'm sorry, it happens at pi over 6 and 7 pi over 6. Okay, now here's where we need to watch out. This is not theta or x. This is twice that. So we want to be on the interval. What they're saying is x needs to be on the interval between 0 and 2 pi, except we're not dealing with x. We're dealing with 2x. That means we're going to go double. We have to double every value. So we're going to go all the way around to 4 pi. So 2x is going to happen at pi over 6. We've already established that. And then it's going to happen at 7 pi over 6. Well, that brings us back here to 2 pi. Well, we got to keep going because we're talking 2x. So if we have 2 pi, which is 12 pi over 6, and I add another pi over 6, that's going to be 13 pi over 6. This is 18 pi over 6 because that's 3 pi right there, plus another pi over 6. That's going to give me 19 pi over 6. So there are my solution sets for 2x. Well, we didn't want 2x. We wanted x. So we're going to take all these radians and divide them by 2. To get x by itself, I would divide by 2. That's the same as multiplying by 1/2. So that's going to be pi over 12, 7 pi over 12, 13 pi over 12, and 19 pi over 12. So those are my answers for this double angle identity problem. Sometimes factoring doesn't work. Sometimes it does. All right. So for this double angle identity, because once again we're talking sine of 2x, let's go ahead and get sine squared x by itself. So sine squared of 2x equals 1/4. I'm going to go ahead and square root both sides. So the sine of 2x is plus or minus. The square root of 1 is 1. The square root of 4 is 2. So I am going to do this, since it's just the sine of 2x, I'm going to do what I did last time with the tangent. I am going to say 2x happens at plus or minus 1/2. And they didn't say how to write my answer, so I'm going to do it in radians. So that is going to be pi over 3 radians as my reference angle coming up here, because this is radical 3. Oh, nope, I got the wrong reference angle. It happens. If it happens to you, remember, just catch it, fix it. I was doing the x, not the y. Boom, right here. It's again pi over 6, because that's going to be at the radical 3 over 2 and 1/2. There's my first positive 1/2. I've got this one. Again, we're talking the reference angle of pi over 6. And that is going to be the point negative radical 3 over 2 and positive 1/2. So there's my positive 1/2. Now I need to do the negative 1/2. The negative 1/2, again, with a reference angle with pi over 6 away from the x-axis. So now we're talking radical 3 over 2 and negative 1/2. There's my first negative 1/2. Coming down this way with that reference angle again. Pi over 6 more than pi. And that's going to be negative radical 3 over 2 and negative 1/2. So these are the angles for when we do one rotation, but we're doubling it. We are doubling it. We want 2x, and so we're up, not equal to 4 pi, it's equal to 0. So we're doubling it, so we want to go all the way out to 4 pi. Well, when we're doing the 2x, as you can see, we got pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Those are all the 2x's. Well, what are we going to do to all of those? We need to find x. So to find my x solutions, we need to divide all of these by 2 or multiply by 1/2. So we're going to have pi over 12 plus 2n pi, because it said for all the solutions, so we need to keep rotating around the circle. And then we're going to say 5 pi over 12 plus 2n pi, because we're going all the way around the circle. 7 pi over 12 plus 2n pi. 11 pi over 12. 11 pi over 12 plus 2n pi, where n is an integer. And we want to specify that n is an integer because we can go positive or a negative rotation. Boom. Alrighty, I know those double angle ones can be a little weird sometimes, but if you got issues, make sure you come to class with those questions. Be ready to ask them, and I'll see you when I see you.